So in section 1.2, we're going to talk about the basics of functions and the graphs. So our objectives for this section are being able to find the domain and range, determine whether a relation is a function, determine whether an equation represents a function, being able to evaluate a function, graph functions by plotting points, use what's called the vertical line test to identify if you have a function or not, and then just being able to obtain information about a function from its graph and identifying the domain and range from its graph and identifying the intercepts from the function's graph. So let's take a look at the definition, the formal definition of a relation. So we're going to be filling in the blanks here. So it says here, a relation is any set of ordered pairs. The set of all the first components of the ordered pairs is called the domain of the relation. And the set of all the second components is called the range of the relation. So here I have written a set of ordered pairs. I've got 4 ordered pairs here. In these ordered pairs, when you write an ordered pair, it's important to have parentheses around the outside of it. And then the first ordered pair is the x value, the second ordered pair, the second number in the ordered pair is the y value. So this right here is a relation. And now in this relation, if I look at the first ordered pair, the first component of the ordered pairs, that is considered the domain. So if I wanted to write the domain, I would list it like this. If any of these numbers were duplicated, I wouldn't have to duplicate them here. So if I had 4, 5, 4, 7, you would just see me write the 4 once. The range is made up, it says here, it is the set of all the second components. So all the second components. Not sure why my highlighter wants to highlight a line there, but this would be the list of the range. And notice I'm putting these braces, and I'm going to separate the numbers with commas. So this would be my range. So you're going to find a problem on the next page. So pause this video and try writing the domain and range here. So this is how you should have answered this problem. The domain is the first component of each ordered pair. Notice how I've separated them with commas and put braces around the outside of the list. And then the range is the second component of the ordered pair. Again, you could put them in ascending order from smallest to highest. You don't need to though, but each of them is separated. Each number is separated with a comma. So continuing on, let's fill in the blank here. The blank here is the word function. A function is a correspondence from a first set called the domain to a second set called the range, such that each element in the domain corresponds to exactly one element in the range. And so we're going to look at some sets, and we're going to decide if the set is a function. So here we have 2 different sets of ordered pairs, and we're going to see if the relation is a function. So we'll start here with the first set. And so I've got the x's are, I'm going to list them out like this. Here are my list of x's. Oops. I have 1, 3, 6, 8. 1 corresponds to 2. 3 corresponds to 4. 6 corresponds to 5. And 8 also corresponds to 5. So I could put my arrow like this. So does this fit our definition? The definition on the previous page, each element in the domain corresponds to exactly one element in the range. So each element in the domain corresponds to exactly one element in the range. This is a function. So yes, this fits the definition. We don't have any of the same first components corresponding to two different y's. So yes, this is a function. And there's no same first components. That correspond to different y's. So we could say we don't have no duplicated x's. Now the next one, let's do the same thing with the next one. Here are my x's. I've got 1, 3, and 5. I wouldn't write out 5 twice, it's the same number. 1 corresponds to 2, 3 corresponds to 4, 5 corresponds to 6, and 5 corresponds to 8. So this one does not fit the definition from the previous page. We've got the duplicated x's here that correspond to two different y's. So we're going to say this is not a function. And the reason why is because 5 produces 6 and 5 produces 8. So it doesn't fit our definition. So if you see duplicated x's that go to two different y values, then you're going to say it's not a function. Let's fill in the blank here. If an equation is solved for y, and more than one value of y can be obtained for a given x, then the equation does not define y as a function of x. Let's look at this on the next page. So it says here, determine whether the equation defines y as a function of x. So we're going to solve this equation for y. So we're going to, if you want to solve for y, let's take this x squared and let's move it to the other side. So I'm going to get y squared is equal to 1 minus x squared. Now, how do I get y by itself? This is not y by itself. This is y squared. I have to do what's called taking the square root of both sides. And when I take the square root, on the left side I'll have y, and on the right side I'll have plus or minus 1 minus x squared. So I have y equals the square root, the positive square root of 1 minus x squared, and I'll also have y equals the negative square root of 1 minus x squared. So because of the plus or minus sign, it shows that one value of x, there are two values of y. So let's write that out. So for one value of x, there are two values of y. So we're going to say that the equation does not define y as a function of x. Now, can I show this a little further? Well, we could think of it like this. So yes, I do see here are two values, but let's put numbers in there, and that might help us see these two values. And I'm just going to pick a random value of x. You can choose any value you want. So let's say an easy value to choose is 0. So let's say if x was 0, what would you get for y here? What would be my value for y? So y is equal to plus or minus the square root of 1 minus x squared. But x, we said, is 0. So I'm going to put 0 in here. And let's see what we get. So we get y is equal to plus or minus the square root of 1. And taking the square root of 1, we would get 1. So when x is 0, we end up with two ordered pairs. We end up with 0, 1, and we end up with 0, negative 1. So it wouldn't fit our definition of a function. So then we would say the equation does not define y as a function of x.